Hi guys, and welcome to this new tutorial. Alright, so now we're going to start the whole process of removing the non so much frequent words of our corpus. And we want to do that because we want to optimize the training, and to optimize the training we need the essential words of the vocabulary. So we're going to remove the words that appear from time to time, less than 5% actually, of the whole corpus. And the first step of this new process of removing the non-frequent words is to create a dictionary that is going to map each word to its number of occurrences. That seems natural. We first need to get all the words separately, and for each of these words we get the number of occurrences, that is, the number of times they appear in the corpus of movie dialogues. So that's what we're going to do in this tutorial. We're going to create that dictionary, and this starts right now. So to create a dictionary, you know how to do it. We first need to choose a name for that, and we want to set everything as clear as possible. So we're going to call that dictionary word to count, because it maps each word to how many times this word appears. That is the count of this word. So word to count, and now we need to initialize it with a pair of brackets, and now we're ready to start the for loop to get all the different words and get their number of occurrences. So we have two separate lists now. We have the clean questions and the clean answers. And so basically we're going to get the words from both these lists, and for each of the words we're going to count how many times they appear. So let's start with the questions. We start with a for loop for question in clean questions. Of course, right now we're dealing with the clean questions, colon, and now let's go inside the for loop. So I remind that clean questions is a huge list containing all the questions. So now what we have to do is go through all the questions in this clean questions huge list, and for each of these questions we're going to get their words. So now we need to make a second for loop that will go through all the words of the question. Alright, so second for loop here, for, and therefore this time it's going to be word in question. Alright, and then to get the words themselves we can add dot split here so that we can get the words directly. So for word in question dot split, colon, and now let's do what we want to do. And what we want to do is now count the number of times this word appears when we go through all the questions of the clean questions list. Okay, so right now we're dealing with a specific word in a specific question. So for this word, either it's the first time we see it, or we've already seen it, and therefore we need to increment the count of this word. And therefore I'm going to make an if condition here to separate these two cases, whether we see that word for the first time or we've seen it already. So I'm going to start with if we see that word for the first time. And to express this in code, we can say if the word not in our dictionary, which we called word to count, well, if this word is not in word to count, then what happens? Well, this word is going to get his first occurrence. We're going to count it once. And therefore, now we're going to take our dictionary, word to count. Then we need to enter the key, which is the word, because now make sure to understand that the key identifier are the words and the values are the number of occurrences of these words. And so the value for this word we're dealing with right now and that we see for the first time appearing in the questions of the clean questions list, well, that value is going to be 1 because it's the first time we see it. But then, other case, if this is not the first time we see this word in a question, well, we can express it with else because this is complementary, else, and in that case what we need to do is increment the count of this word, increment the number of occurrences, because we've already seen it before and therefore we need to increment its number of occurrences. And so what we can simply do, I'm gonna copy this because the way to increment in Python is pretty practical. We just need to add here plus equals 1. That is equivalent to word to count word equals word to count word plus 1. So we increment it. Perfect. So that's it. With this double for loop here, we count for each word appearing in all the questions of the clean questions huge list, the number of occurrences of these words. And now we're going to do the same for the answers because there are some other words in the answers. But good news, it's going to be almost the same. I'm going to copy this for loop here, paste it below, and now we simply need to replace question by answer. Very simply, it's the same logic. So there we go. Let's do that quickly. Answer, clean answers for word in answer.split. If word not in word to count, that's the same. We use the same dictionary. Word to count word, word to count word. Perfect. See? Done. Wonderful. Perfect. So now let's execute these lines, this code section to create this dictionary. It's going to take a while because, well, no, not that long, because we go through all the words of all the questions and all the answers. But there we go. That's done. We have this dictionary created, which will be very useful for us to remove the words that are below a certain threshold of frequency. That was the first step. Now we're going to move on to the next step, which will be to actually choose this threshold and then count the number of words that appear more than this chosen threshold. And we will do that in the next tutorial. Until then, enjoy Deep NLP. Hello and welcome to this new tutorial. This one is very special and very important because we're going to do two essential tasks of NLP, which are tokenization and filtering the non-frequent words. We're going to do that at the same time by creating two dictionaries, one that is going to map each word of all the questions to a unique integer, and one other dictionary that is going to map all the words of all the answers to a unique integer. And while creating this dictionary, we will add an if condition that will check if the number of occurrences of the word we'll be dealing with in the loop will be higher than a certain threshold that we will choose in this same tutorial. And if that's the case, we will include that word in this dictionary. This word will be one of the key identifiers of the dictionary. And on the other hand, if the number of occurrences of the word is below the threshold, well, we will not include this word in the dictionary. So that at the same time, we proceed to the process of tokenization by getting separately all the different words of all the questions and all the answers and attributing a unique integer to each of these words. And at the same time, we filter out the words that don't appear frequently in the dictionary, that is, that are below the threshold that we're going to choose. And speaking of the threshold, this is the first thing we will do in this tutorial. We will choose a number for that threshold, and for the words having a number of occurrences below this threshold, we will exclude them. So let's do it. Let's start by choosing this threshold. So we're going to call it naturally threshold. And in general, when doing this kind of task in NLP, I recommend to filter out the 5% that appear the least in the whole corpus of words. And considering the total number of words in our corpus of words, well, a good threshold for our situation would be between 10 and 20. Remember, you can experiment with different hyperparameters, different values for the hyperparameters. The threshold is one of them. So I'm going to choose 20 here. That will give us a removal of 5% of the least appearing words, but feel free to either increase the threshold, that will reduce the training time, or if you have a powerful computer, you can also try with a lower threshold, but not too low because then it will be too overwhelming for the model to learn. So here we're going to choose 20, and there we go. Let's create now our two dictionaries. One dictionary that will map each of the questions words to a unique integer, and one other dictionary that will map each of the answers words to a unique integer. So let's start with the dictionary for the questions words. And in the spirit of making all our variable names clear, we're going to call that dictionary questions words to int, because we're mapping all the questions words to a unique integer. So questions words to int, and as usual, we initialize it with some brackets like that. All right, then we are used to directly getting to a for loop, but first we need to initialize a variable to 0, which will be the number of occurrences of the word we will be dealing with in the loop, because we're going to loop over the words in the word to count dictionary that we created before. You're going to see, but we need to introduce a new variable right now that we're going to call word number, and we will initialize it to 0 because basically we're counting from 0. And now we can start the for loop. So for, and as we say, we loop over the words of our previous dictionary, so loop variable word, and also count, because for each of these words we're going to get the number of occurrences of these words, which we will get thanks to our word to count dictionary that we created before. So word count in, well, we can get the words and the count of the words in that same entity, the word to count dictionary. So that's in word to count, and to get them we need to add here dot and items with parentheses. And this will get us the words, which are the key identifiers, and the number of occurrences, which are the values of the key identifiers in the word to count dictionary. So colon, and then let's start the for loop. So as I said at the beginning of this tutorial, now we have to make an if condition to make sure we include only the words that appear a number of times higher than the chosen threshold, which is equal to 20. So what I'm going to add here is an if condition that will check if the count, which is the value of the dictionary associated to the key identifier word, the word we're dealing with right now, the loop. So if count, that is the number of occurrences of this word, is larger than the threshold, well, what are we going to do? We can even include the threshold if we want to keep the words that appear at least 20. That's not a big deal. That won't change much, but we can include it. And if that's the case, what do? Well, we will include that word in the dictionary that we're creating right now and that we're calling questions word to int. And therefore, right now I'm taking this dictionary, I'm copying that, I'm pasting that here. And so you know the trick. I'm going to create the key and the value at the same time. And the key, which appears in the square bracket, is the word we're dealing with right now and that we choose to include in this dictionary because its number of occurrences is larger than the threshold of 20. So questions word to int word. We just created the key and now we must associate it to it the value, and the value, as we said, is a unique integer, right? Because our dictionary maps the questions words to a unique integer. And that's what this word number will be useful for us right now. It's because we're going to simply create these unique integers by starting from 0. So the first word that we find appearing more than the threshold will be associated to 0. Then the next one that we find appearing more than the threshold will be associated to 1. Then the next one to 2. Then the next one to 3. Well, you get the idea. We will increment the word number each time we find a word appearing more than the threshold. And therefore, the value associated to this key identifier word in our questions words to int dictionary is the word number variable. For the first word, 0, but then we will increment it right now so that the next word we find appearing more than the threshold will get the incremented value of the word number variable. So right now what we gotta do is increment word number, and that's why I'm adding here plus equals 1, which is exactly the same as word number equals word number plus 1. Therefore, the next frequent word will have the key identifier 1, then the next one after that will have the key identifier 2, etc. Alright, and that's it. That creates our questions word to int dictionary. So we get this dictionary that encodes each of the words of the questions by at the same time only including the frequent ones, or at least the 95% most frequent one. And now we're going to do the same for the answers. We're going to create a new dictionary that we're going to call answers words to int, and that will do the same. It will not only include the 95% most frequent words of the answers, and at the same time associate them to a unique integer. And so you get that this is exactly the same logic. We just need to copy this, copy, and I'm gonna paste that just below. There we go, and like before, we just need to replace question by answer and we will be good to go. So questions word, I'm gonna replace that by answer. Answers words to int, perfect. Word number, we can keep that because it was only used for the previous for loop, and therefore we can reinitialize it to 0 because that's it. By this code section here, we get our dictionary, so we can just use it again, that's fine. So word number is fine. Then for word count in word to count items, all good. If count is larger than the threshold, well, our answers words to int dictionary will create the word key that was accepted because it appears more than the threshold, and the value word number, which is its unique integer, identifying and encoding it. And here eventually that's the same, we just need to increment the word number so that the next word that we find appearing more than the threshold gets a new unique integer to be encoded with. There we go, our two dictionaries are created. We not only removed the 5% least frequent words, and at the same time we encoded all the words of our questions and of our answers. So that's a good thing done. So now we're going to execute this section to have a look at our two dictionaries that we just created. There we go, we have them, all good. So let's have a look. First, let's have a look at the first one corresponding to the questions, which is right here, questions words to int. And there we go, we get all the words of the questions, and for each of them a unique value identifier, which is of course an integer. All right, so you get all the words here, and that will be very useful for our future sec-to-sec model, and in general way that's the common task to do in natural language processing. Of course, you understand that right now we are only doing natural language processing. We have not attacked deep NLP yet. The deep part will come when we get to the deep neural networks. That is when we get to the sec-to-sec model. This, what we're doing right now, is just the common process in NLP, but that's of course very important. And let's have a quick look now at the answers words to int dictionary. So that's the same, you have all the words and a unique integer for each of these words. Alright, perfect, so let's close this and now let's move on to the next step, which will be quite simple actually. It will be to add the final unique tokens to our two dictionaries that we just created, and that's basically the end of strings, start of string, SOS, well, the last unique tokens that we need to add to our dictionaries, which are essential tokens to consider when building the sec-to-sec network. So we'll do that in the next tutorial, and until then, enjoy Deep NLP. Hello and welcome to this new tutorial. In this one, we're going to add the last tokens to our two previous dictionaries that we just created, and these last tokens are the ones that are useful for the encoder and the decoder in the sec-to-sec model, which are, the start of string that we're going to encode by SOS, the end of string that we're going to encode by EOS, the pad, which is very important for our model because the process training data and the sequences in the batches should all have the same length, and therefore we have to input this token in an empty position. And eventually we will create a last token, which we will call out, and that corresponds to all the words that were filtered out by our two previous dictionaries. Thanks to these dictionaries, we know which words are not the 5% least frequent words. So later on in one or two tutorials, we will use these dictionaries to replace all the words, all these 5% least frequent words by this token out, so that these 5% least frequent words are all replaced by one same common token, which will be out. So that's why it's very important for us right now to create these tokens and, of course, add them to our two dictionaries, questions words to int and answers words to int. So let's do that. Let's start by creating our list of final tokens. So we're going to name that list tokens. And remember, a list is in square brackets. And inside, we just need to input these tokens. So the order is important here. Otherwise, this won't work given the sec-to-sec implementation that will follow. The first one should be the pad. Inside this pair of symbol, we input what we want and we will call it pad. All right. Then the next token should be the end of string, which we also need to put in quotes and in these math symbols. So the end of string, we're going to call it EOS. That's the classic way to call it. You will see that in a lot of papers and a lot of documentation. EOS, end of string. Then the next one will be the token by which all the words that were filtered out by our previous dictionaries will be replaced. And as we said, we want to call it out, as in filtered out. So out. And finally, the last token we need is the start of string, which, remember in the intuition lectures, is the first token that should start in the decoding layers. You know, when we decode the output of the encoder, which is the context, well, the first element of this decoding is the start of string. That's very important. So that's why we need to include it right here, same in quotes and in these math symbols. And we're going to call it the classic way, SOS, start of string. All right, so we have our tokens and now we just need to add them to our previous dictionaries. So now we're going to make two for loop, one for loop for the questions words to in dictionary and one other for loop for the answers words to in dictionary. And this will be the same for loop, so we will just do a copy paste once we make the first one. So for, then, well, we want to basically loop over all these tokens here. So the loop variable is going to be called token. For token in tokens, very simply, then colon, and inside we just need to add each one of these tokens to our questions word to int dictionary. And you know how to do this. The trick is just to take our dictionary, questions words to int, so I'm copying this, and I am pasting that here. Then in square brackets, I just need to enter this new key that I'm creating, that I'm adding to my dictionary. And this new key is the token we are dealing with right now in the loop. So that's the key, because remember, the keys identifiers in the questions words to int dictionary are the words, that is, are the tokens. And then the values are, of course, some integers. Remember, it maps the questions words to a unique integer. So what integer could we choose here? Well, it must not be one of the integers created here in this previous code section, in this for loop here, but very simply we can just take the max plus 1 of all the integers that we created here. And since these integers were added from 0 to 1 to 2 to 3, etc., well, we can simply take the length of the questions words to in dictionary, because the length of this dictionary corresponds to the total number of keys of this dictionary, and that is the total number of values. And since we counted from 0 to this total number of keys, well, we can simply take here the length of this dictionary plus 1. And with this, we'll be sure that we have a unique integer for our new token. So I'm going to add here len, then I'm going to paste my dictionaries again, and I'm going to add plus 1 as we just said. And that's it. This loop is done. Because when we're done dealing with this token here in the loop, we will get to the next token, but the length of the questions word to in dictionary will have changed because we will have just added a new token, and therefore we're safe here. The next token will have a new unique integer. So that's perfect. That works this way. And simply we can move on to our other dictionary for the answers, which is answers words to int. And as I said, it's exactly the same logic. We just need to copy this, paste that here, and just replace question by answer. There we go, answers words to int, and same here, answers words to int. All right, and that will do it. So now we simply need to select these lines and execute. There we go, we now have our final tokens, the essential tokens for the sec-to-sec model, added to our two dictionaries. Perfect. Now we're going to move on to the next step, which will be actually very quick and easy because we just need to create the inverse dictionary of the answers words to in dictionary. And why do we need to do that? That's because we will use this inverse mapping when building the sec-to-sec model. So we simply need to do that quickly, and then we'll move on to the last final steps of data preprocessing, and we'll quickly get to part 2, building the sec-to-sec model. So I can't wait to get there, and until then, enjoy Deep NLP. Hi guys, and welcome to this new tutorial. In this one, which is going to be quick and easy, we're going to create the inverse dictionary of the answers words to int dictionary. Why do we need to do that? That's because we will need the inverse mapping from the integers to the answers words in the implementation of the sec-to-sec model, and we actually just need it for the answers words to int dictionary and not the questions words, so this will be very quick. And the other reason why I wanted to make it a separate tutorial is that in Python, you have to know the trick to inverse a dictionary. That is to get the inverse mapping of a dictionary and put that in the dictionary, because you will need to do that a lot, whether you are doing deep learning, NLP, or other kind of coding. You need to know the trick to inverse a dictionary. And so since we need it here, I think that's perfect for you to get the trick. So let's do it. It's actually going to take one line of code. It's very easy to do once you know the trick. And we need to start by choosing a name for that dictionary, because we're creating a new dictionary, which will be the inverse dictionary of the answers words to int dictionary. So, well, you can guess what this name of the dictionary is going to be. Since we're doing the inverse mapping, we're mapping from the answers integers to the words, and therefore we're going to call that dictionary answers int to word. All right, so that's our new dictionary. And the trick now to inverse the mapping is just to do this. Dictionaries are always in brackets like that, but then we're going to make a for loop inside these brackets. And so what we're going to do is introduce a new variable here, which will be one of the loop variables that I'm going to call w_i, because it corresponds to word integers. So that's going to be the integers of the words in this new dictionary. So w_i colon, then w, which will correspond to the word. And now it's important to understand that w_i corresponds to the values of the dictionaries, and w here corresponds to the key identifiers to this new dictionary. All right, and then we need to start the for loop. So we add here for, then we need to take our words again, w, comma, our word integers, w_i, and these guys, we're going to take them from our previous dictionary that we're trying to inverse the mapping. And that is the answers words to int dictionary. So I'm going to take that here, copy, and paste that here. Answers words to int, but then be careful to make sure we get w, that is the words which are the key identifiers in the previous dictionary, and the words integers w_i, which are the values of this same previous dictionary. Well, we need to get them by adding dot items and parentheses. By adding dot items parentheses, we will get separately the words, that is the key identifiers, and the words integers, that is the values of the dictionary. All right, and then that's it. You now know how to inverse the mapping of a dictionary by creating a new one, which is the inverse dictionary. So perfect, let's execute this. There we go, executed, and now we have our inversed dictionary for the answers. We can have a look. Where is it? It is actually right here. Answers int to word. Let's have a look. And perfect, this is exactly what we want. As you can see now, the keys are the integers, and for each of these keys we have different words. So we clearly have a mapping from unique integers to unique words. So that's perfect. We now got what we wanted, which will, I remind, be useful for the implementation of the sec-to-sec. So we're done with this new step. Now we're going to move on to the next step. It's almost over. We have 3 or 4 steps left. We now need to add the end of string token, the EOS, that we created in the previous tutorial, this one here, to the end of every answer. And that's very important because that's for the decoding part of the sec-to-sec. In the decoding part of the sec-to-sec, we need to end the decoding with this EOS token end of string. So we need to add this token at the end of every answer. We will make a quick for loop for that. That will be easy. And then we'll move on to the last 2 big steps of this data preprocessing part. And by the way, this natural language processing part, because we're clearly doing some natural language processing that will considerably improve the training process. So we'll do that in the next tutorials, and until then, enjoy Deep NLP. Hello and welcome to this new tutorial. In this one, again, a quick and easy one, we're gonna add the EOS token, the end of string, to the end of every answer. So as you might guess, we're gonna loop over all the answers in our clean answers list. We're gonna get back to the original clean answers list, which is the list of all the answers but that we cleaned one by one. And to each of these answers, we're gonna add this EOS string. All right, so let's do this. Well, since we already have the clean answers, it is already existing, we don't need to introduce anything here as we used to do before. We can directly start the loop. And so I'm starting here with 4, and now we need to choose a loop variable. So we're gonna simply loop over all the indexes of the clean answers list. Let's have a loop at it again. Clean answers list is right here. So yes. And as you can see, this is just a list of cleaned answers that we can get with the index here. Index going from 0 to the length of this clean answers list. So we're gonna choose an arbitrary index I for the loop variable that will go through all these indexes. All right, so let's do this. For I in range, and in parentheses, we need to input the length of this clean answers list. So I'm taking len clean underscore answers list, which corresponds to the number of elements of this clean answers list. And therefore, we will go through all the answers one by one. And for each of them, what are we going to do? Well, we're going to add, in the end, the end of string token. So let's do this. To get these answers, we simply need to take our clean answers list, then get the ith index, which is the index we're dealing with right now in the loop of the answer, and clean answers I will give us directly the answer. And so what do we need to do with that answer? Well, we need to add the end of string token at the end of it. And the trick to do that, it's like an incrementation. We can add a plus here, plus equals, because clean answers I plus equals actually means clean answers I equals clean answers I plus something. And this something coming after the plus is going to be, of course, the end of string token. So I'm adding some double quotes here because this end of string token has to be input in double quote. That's when we do an addition operation between the elements of a list. So quotes here, let's not forget them. And then we need to add the end of string. However, be careful to make that separation between the last word of the answer and this end of string token. We need to separate them by a space. And therefore, I just added a space here, and then we can add the token EOS. All right, perfect. And that's it, the loop is done. So that was pretty easy. And I remind that we are doing this because the end of string token is needed at the end of the decoding layers of the sec-to-sec model. We have to specify the end of the answer in the decoding part by this end of string token. And that's why it's important to add it in the end, as we just did. All right, so great. Let's execute this. Execute. There we go. Perfect. Now let's check that it is right here in the clean answers list. Yes. All right, so I'm going to expand this, and there we go. It is at the end of every answer in the clean answers list. And as you can see, it was necessary to add the space here so that it can clearly distinguish the last word and the end of string token. Otherwise, it would confuse this, for example, do EOS with one same token. So now we understand better the space. All right, so perfect. That's another step done. So now what do we need to do left? Well, we have 2 remaining steps in the data preprocessing. I'm pretty excited to be almost done with it, because this is not the funniest part, but we're almost done. And actually these last 2 steps will be easy. The first one will be to remove all the non-frequent words, that is the 5% least frequent words, from all the questions in the clean questions list and the answers in the clean answers list. We need to do that. Besides, we will need to do a last conversion to convert all these cleaned and filtered questions and answers to integers. That will be our last needed conversion. And why do we need to make that conversion? That's because in the end, which is our final step, we will sort the questions and the answers by the length of the questions. And this is very important to do for the training to improve it, make it shorter, and optimize it. So we will do these last two steps in the next two tutorials, and until then, enjoy Deep NLP. Hello and welcome to this new tutorial. So in this one, we're going to translate all the questions and all the answers separately into integers. What does that mean? Well, let's take our clean questions, for example, the clean questions list here. In this list, you can see that we have all the questions that are into text. So can we make this quick? Roxanne, Corinne, and Andrew Bard are having. These are into text, and we want to translate that into the unique integers that were mapped thanks to our previous dictionary that we created. So basically, we just need to translate all this into this new language of integers according to how our previous dictionary was made. And therefore, we're going to have to make some for loops to loop not only over all the questions here, and then all the answers. And then for each of these questions here, we will loop over again all the words of the question and applying the previous dictionary to translate each of these words into their unique associated integers. All right, so let's do this. And by the way, now that you understand what we have to do, well, again, I recommend to try doing it yourself before watching this tutorial. And the other important thing is to understand why we're doing this. We're only doing this because then we want to sort all the questions and all the answers by their length. And to sort that, well, these two lists of questions and answers translated into integers will be very helpful. And why do we want to sort the questions and answers by their length? That, I remind, is to optimize the training performance. All right, so let's make our two lists of questions and answers translated into integers. And also, while making that list, we're going to replace all the words that were filtered out by our token out. So at some point in the for loop, we will need to add an if condition to check if the word was filtered out. And if that's the case, we will replace this word by the token out. So let's do this. Now you understand what you have to do. Try to do it before me, but I'm going to start now. So to start, we have to understand that we're about to make a new list, and this will be the list of the questions translated into integers, and I'm going to call that list questions underscore to underscore int, because we're translating the questions into integers. So questions to int, and then a pair of square brackets because it is a list, and now we are ready to start the for loop. So as we said, we have to do two for loops. First, we need to loop over all the questions here. That's the first for loop. And then the second for loop, for each of the question, we will loop over all the words of the questions. So let's do this first for loop over the questions in clean questions, the huge clean questions list of all the questions in text. So for all the questions in clean questions, what do we want to do? Well, we want to translate all the words of the question into their associated words based on the previous dictionaries. So we need to make another for loop, but we are going to create a new list for each question and the question we're dealing with right now. So since we're making a new list, we need to introduce a new one. And we're going to call it ints, because this will be the list of integers. Each of the integers will be the associated integer to the word in that question. So ints equals, we initialize it as an empty list, and there goes the second for loop. And in the second for loop, we will loop over the words in the question. So in question, then don't forget we need to add dot split to get these words separately, and then colon, and then there we go, time for the if condition, because that's where we need to check if the word was filtered out or not. If it was filtered out, we will replace it by the token out. If it was not filtered out, we will just translate it into the integer. So let's do this. Let's make this if condition. So we're first going to check if this word was filtered out. That is, if this word is not in our dictionary questions word to int. Remember, that's the dictionary that maps each word of the question to an integer. So that's exactly what we need right now. If this word is not in this questions words to int dictionary, well, what do? We want to replace that word by the token out. And more specifically, we want to replace that word by the integer that encodes the token out. Remember that in this code section here, that is 3 tutorials ago, we also attributed a unique integer to each of the tokens here. One of them is out. And therefore, out also has its unique integer. And now, not only we want to replace this word by out, but more specifically, we want to attribute for this word the unique integer that is associated to the token out. And therefore, what I'm going to do now is I'm going to take my ints list to which I'm going to append this unique integer associated to the token out. And how do we get it? Well, we simply need to take our dictionary, questions, words to int, and from this dictionary, we're going to get the key, the token out, which is this way. The token out is the key that will allow us to get from this questions words to int dictionary the unique integer that was associated to out. And this is what will be returned here. So this is exactly what we want. Great. So now, other case, if the word is in questions word to int, that is, if the word wasn't filtered out, which we can express here by else, because this is complementary, well, in that case, what do we want to do? Well, we simply want to add to our ints list of the encoded integers the unique integer that was associated to this word we were dealing with right now and that was not filtered out. So we're going to do that same thing. I'm going to copy this, paste that here, but instead of taking out here, we of course need to take the word, because the word is now the key identifier, which when we apply the questions word to int dictionary will get us the unique integer associated to that word, which is exactly what we want. So now that we have the question translated into integers, we simply need to append this translated question into integers to our questions to int huge list of all these translated questions. And therefore, what we simply need to do here is take, well, we can copy this. We take our questions to int list to which we append the question translated into integers, and that is contained in this ints list. So in the append function, I'm just adding ints. All right, and that's it. That does the job for the questions. And now we're going to do the same for the answers. But as usual, it's very easy. We simply need to copy paste this whole section because this is going to be the same logic. So paste, and here we just need to replace all the questions by the answers. So let's do this. Answers. All right, good. So we did it. If it's more clear for you, we can even add questions into integers so that it is clear that this is the translation of questions text into integers. So just replacing that here. All right. And so now let's have a look at what we just made. I'm going to select all these sections and execute. There we go. I hope it's going to work. Hope no error was made. Apparently not. Let's have a look. So questions into int first. Let's have a look. It must be right here. Questions into int. Yes. And perfect. This is exactly what we wanted. Each of the question of the clean questions list was translated into the unique integers according to our questions words to int dictionary. And so perfect. So let's quickly check also the answers into int list, but that should be the same. Yeah, there we go. Perfect. All the answers in the cleaned answers list were translated into their unique integers based on that answers words to int dictionary that we made. Great. So wow, now I'm getting super excited because we're getting to part 2, building the sec-to-sec model. We only have one tutorial left to take care of, but that's very important because that's the one where we'll sort the questions and the answers by their length. And to do that, we will use what we did here, that is these questions into int and answers into int lists that we will leverage to sort these questions and answers by their length. So let's do that in the next tutorial, and until then, enjoy TPNLP. Hello and welcome to the final tutorial of part 1 data preprocessing. I'm super excited to be almost done with it because I can tell you that what's coming next is going to be really exciting. We're going to build the brain, we're going to get into deep learning. Between us, deep learning is much more exciting than natural language processing, so that's why I'm super pumped to get to deep learning. But that will be in the next tutorial. In this one, we're gonna tackle the final step of our natural language processing phase, which is to sort the questions and the answers by the length of the questions. Be careful, we are sorting both the questions and the answers by the length of the questions. So first of all, why do we want to do that? Well, I mentioned it in the previous tutorial, but I'll say a little more here. Basically, we want to sort the questions and the answers by the length of the questions because this will speed up the training. This will speed up the training and help to reduce the loss. And the reason for this is that because it will reduce the amount of padding during the training. So it's pretty technical, but it's important to know why we're doing this. Remember, I told you at the beginning of our adventure here, it's always important to know where you come from and where you want to go. And so right now, where we want to go, what we want to do is to sort the questions and the answers by the length of the questions to speed up the training and optimize it. All right, so let's do this. Let's sort these questions and answers. So we will have to make some new lists because we cannot change the order in an existing list. This is not possible in Python. We have to make a new list. Or we could override the previous list, but it's dangerous to do that, so we'll make a new list. And we'll make actually 2 new lists. The first one, we're going to call it sorted clean questions. Sorry for the long names, but it's just for you to visualize clearly what we're making. Sorted clean questions that we're going to initialize as an empty list. And then same, we're going to make the sorted clean answers that we are initializing as well as an empty list. Sorted clean questions and sorted clean answers. Great. Now starts the for loop. And actually there are going to be 2 for loops. And again, I recommend to try to beat me and make these lists before me. That's an excellent practice. The more you code, the better you'll become. But I'll start right now. So, for, and so now what we want to do? Well, we want to sort the questions and the answers by the length of the questions. So what we'll do is we will get a loop variable that is going to go from 1, which is the shortest length of a question or an answer, like for example, why or yes or no. You know, these are important questions or answers in a conversation. So we're going to have this loop variable that is going to start from 1, and then that is going to be incremented by 1 to be equal to 2, then 3, then 4. But then we will make it stop at a certain length because we don't want to include the questions that are too long, like for example, some big texts. This will not help the chatbot to learn how to speak. It's like if you're training a child to speak English or French, well, you will not teach him English with long sentences. You will start with some short sentences. Otherwise, the child will get overwhelmed. So the idea is going to be the same here. We just want to include the questions and the answers that are not too long. And by not too long, I mean a length, for example, up to 20 or 25. So we'll choose 25. If this is too long for you, you can always reduce it. If the training takes too long, you can always reduce it. So I'll go up to 25 here. We'll see what happens. Don't worry, if we don't get good results, we will always go back in our code to improve the chatbot in the end. So there we go. I'm taking my loop variable that I'm calling length, and that will go in the range from 1, the shortest length of a question, the shortest question, up to 25 plus 1. I'm adding the plus 1 here because remember that upper bounds in ranges in Python are excluded. So in order to go up to 25, we need to add 25 plus 1. But you know, this is arbitrary, so we could always go up to 24 and not include the plus 1 here. And actually, let's do this. It's proper. Feel free to do it if you want. All right, so then colon, and we're ready to go inside the for loop. And the next step is to start a second for loop. Because now that we loop over the different possible lengths of the questions we will be dealing with, well, now for each of these questions having that length we're dealing with right now, well, we want to get two important elements. The first element is the index of the question, and the second element is the question itself, the text, because then we will need the length of that question. So the trick to get these two elements at the same time is to use the enumerate function. And so that's exactly what we're going to do. We're going to enumerate the questions into int list. So I'm going to show you what it means. The questions into int list is this one. Yes, this is this list. And by taking the enumerate function, what will happen is that the loop variable is going to get two elements. First is the index of the question in this questions into int list. And the second element is going to be this question itself translated into integers. And that's exactly what we'll want, because we need to keep track of the index to add it in our future sorted clean questions list and then sorted clean answers list. And also we need this because we need the length of it to sort the questions. We will get the length and see if it is equal to the length of the loop starting from 1 and then be equal to 2, 3, up to 25. So we need these two elements, and the trick to get these two elements, the index and the question, is to use the enumerate function. So there we go. Let's start the second for loop. For, then we can choose any name for the loop variable and we will call it I. It's the usual name when using enumerate. For I in enumerate, that's the function, and questions into int. And colon, and let's go inside. So, for example, the first I is going to be equal to the couple of 0 and this question. Then, at the next step of the loop, I is going to be equal to the couple of 1 and this question. Then, at the next step, the couple 2 and this question. So you see how this works? By using this, we get the index and the question itself. So that's perfect. You're going to understand very quickly why it's important for us to get these two elements. And so now what I'm going to do is I'm going to check if the length of the question I'm dealing with right now in questions into int is equal to the length we're dealing with right now in the first for loop. Remember, this length starts as 1. So if the question that we're catching here in questions into int has a length of 1, well, we will include it first in the sorted clean questions. That's the idea of what we're doing here. And then when length will be equal to 2, we'll catch all the questions in questions into int that have a length equal to 2. And then etc. And that's how we manage to sort the questions and the answers by the length of the questions, because now in this for loop, we will just add first an if condition to check if the length of the question is equal to the length we're dealing with right now. And if that's the case, we will append this question to our sorted clean questions and our sorted clean answers. All right, so let's do this. Let's make this if condition. If the length of the question we're dealing with right now in this second for loop, and this we can get it by I bracket 1, because remember I is a couple and the first element of the couple is the index of the question and the second element of the couple is the question itself. So now we're checking if the length of the question itself is equal to the length of the first for loop we're dealing with right now, and that starts at 1. So if the length of the question is equal to this length, then what's going to happen is that we will have to append this question to the sorted clean questions list, because this length starts at 1, and therefore the length of the question is equal to 1, and therefore this is the shortest question. All right, so we take our sorted underscore clean underscore questions list. And to this list, we append that question that has the length 1. All right. And how can we get this question? Well, we take our questions underscore into underscore int huge list. And then to catch this question, we need to catch it by taking the index of the question we're dealing with right now. And the index, we have it because this is the first element of I, because I remind, is a tuple containing the index of the question and then the question itself. So to get that index, we need to say here I0. And that gives us exactly what we want. All right. And remember that we also want to sort the answers by the length of the questions. And why is that? That's because we want to align the questions and the answers. We want to make sure that at a specific index, the answer of that index is the answer to the question of that same index. And therefore, that's why we have to choose something to sort the questions and the answers by. And we're choosing to sort them by the length of the questions. And therefore, what we need to do now is directly to append the answer of that same index, I0 here, to our sorted clean answers list. And therefore, what I'm going to do is I'm going to copy this, paste that here, replace sorted clean questions by sorted clean answers, and append, of course, answers into list of I0, because answers into list of I0 contains exactly the answer of index I0, which is the answer to the question of index I0 in the questions into int list. So that makes sure everything is well aligned here. So perfect. Oh my goodness, we are done with data preprocessing. This feels so good. I'm super happy to eventually get to part 2. But before we do that, let's have a look at the beauty of what we just made with these final 2 lists, sorted clean questions and sorted clean answers. So I'm going to execute this. I hope I didn't make any mistake. And let's execute. There we go. Fingers crossed, and amazing. Now I can tell you that the data preprocessing phase is done and NLP is done actually, because now we're going to get to deep learning, which is much more exciting. So let's have a look at our sorted clean questions and our sorted clean answers, which are right here. So sorted clean questions first, and what we should see is, yes, exactly that. That is the first questions containing only one element. So this corresponds to the encoded number that results from the encoding thanks to our previous dictionary questions word to int. So these corresponds to one word questions. And if we scroll down, well, we should get to questions with more elements. So we should get from questions with one element to questions with 2 elements in any second. Well, there are actually a lot of questions with 1 element. I wonder what these kinds of questions are. But soon enough, we should get to questions with 2 elements. There we go. They are right here. So that's the questions with 2 words, like, I don't know, like, what's up? No, what's up would be what is up. So that would be a 3 words question. But that can be, for example, how come? Or you okay? I don't know. Well, you know, these are questions from movies, so this can be anything. And then soon enough, we should be able to get to 3 words question. So let's see. There we go. 3 words question. So here, what's up is a 3-word question. I'm sure there is a what's up somewhere. Anyway, this is exactly what we wanted. So that's perfect. I'm going to close this. All right. So now we can move on to part 2, building the sec-to-sec model. And if you're still there with me, I want to congratulate you very much for staying with me along this huge data preprocessing phase. I hope this wasn't too overwhelming, but this is compulsory in deep natural language processing. And on a more general note, keep in mind that the work of a data scientist or a machine learning scientist is 70% on data preprocessing. But I try to make it as efficient as possible. And now things are going to get exciting. We're going to get into TensorFlow. We're going to start using TensorFlow. And we're going to create the encoding layer and then the decoding layer in the sec-to-sec model. I can't wait to start, and until then, enjoy Deep NLP. Hello and welcome to part 2, building the sec-to-sec model. Eventually, we're getting there, and that is in this part that we're going to start using TensorFlow to build the architecture of the chatbot. That is the architecture of the sec-to-sec model, which is at the heart, at the core of the chatbot. So in the previous part, we made a lot of for loops. Now I guess you are an expert in for loops. And now in this part, you're going to become an expert in another Python technique, which is functions. We're going to make a lot of functions in this part because these are going to be the functions that will define the architecture of the sec-to-sec model. So actually, we're going to make one function per tutorial. And the function we're going to start with right now is going to be a function that will create placeholders for the inputs and the targets. So what is a placeholder and why do we need to create it? That's the first question we will answer right now. So in TensorFlow, all variables are used in tensors. Tensors are like an advanced array, more advanced than a NumPy array, which is of a single type, and that allows fastest computations in the deep neural networks. So we need to go from the NumPy arrays, the classic NumPy arrays, to tensors, but that's not all. Because then in TensorFlow, all the variables used in tensors must be defined as what we call TensorFlow placeholders. So basically that's an even more advanced data structure that can contain tensors and also other features. So that's always the first thing we must do when starting to build a deep neural network with TensorFlow. We need to create some placeholders for the inputs and the targets. And that's exactly what we're going to do right now. But we're going to do it through a function that we will call model inputs. And so inside this function, we will create a placeholder for the inputs, a placeholder for the targets, and then we will add a learning rate and even more hyperparameters. So in short, we are creating these placeholders to be able to use these variables in the future training. All right, so let's define this function. To define a function in Python, we need to start with def. Then we need to give a name to that function, and we're going to call it model underscore input. And this function is not going to take any arguments because it will just directly take the input and the output, and for each of them, convert them into placeholders, into TensorFlow placeholders. So that's all good. Colon, and let's go inside the function. All right, so we're going to start by creating some new variable that we're going to call input, and that will be this TensorFlow placeholder containing the inputs. And so to create a TensorFlow placeholder, well, first we need to call our TensorFlow library, which we can get thanks to the shortcut we made, which is tf. So we call TensorFlow, and from TensorFlow, we're going to get the placeholder function. That is a function that can create placeholders for the inputs. All right. So now in this placeholder function, we need to enter 3 parameters. The first one is going to be the type of the data that are the inputs. And remember that we converted our inputs into unique integers in part 1 data preprocessing. So the type that we will choose here is going to be tf, we need to call it from TensorFlow, dot int 32. All right, then next argument is going to be the dimensions of the matrix of the input data. And since the inputs are the list of the questions encoded into unique integers, we can have a look at it again, sorted clean questions, which you must understand are the inputs. You can see that these inputs are lists of integers, and therefore with the padding we will get a 2-dimensional matrix. And that's why right now we need to specify this, that it's a 2-dimensional matrix. And to do this, we're going to add here in brackets, square brackets, none and none. That's a way to specify that our inputs are 2-dimensional matrix. All right, and then the last argument is just a name that we have to give to the input. And we specify this with the argument name equals, and we can put in quote, input. All right, perfect. So that creates the placeholder for our inputs. Okay. All right, and now we're going to do the same for the targets. So I'm copying this because it's going to be almost the same. I'm pasting that here. I'm replacing here inputs by targets. And same, we have to create a TensorFlow placeholder that will contain these targets data. Then of course the target data is composed of integers because they correspond to the encoded integers that encode the words of the answers. Remember that the answers are the target, and then we're going to compare the chatbot answers to the real answers, and that's how it will train itself to speak like a human. And then same dimension for the matrix of the target, none to say it's a two-dimensional matrix. And then of course we need to change the name of the input here by target. All right, so perfect. We have created placeholders for the inputs and the target. And now we're going to create two more TensorFlow placeholders, which are going to be simple ones. One that will hold the learning rate, which is a hyperparameter, and one that will hold the popular keepProb hyperparameter, that's the way we call it, and that is just a parameter used to control the dropout rate. You know, the dropout is the rate of the neurons you choose to override during one iteration in the training. Usually the dropout rate is 20%, so that you deactivate 20% of the neurons during the different iterations of the training. And so this keepProb parameter, for which we're going to create a placeholder, will be used to control this dropout rate, because sometimes the dropout is too high, so we will need to reduce it, and sometimes it is too low, so we will need to increase it, and this will be done by the keepProb parameter. All right, so let's create these last two placeholders for the learning rate and keepProb. So let's do this. Learning rate first. I'm going to paste actually what we copied before, replace inputs here by LR. Then the learning rate is not an integer anymore, but a float, so float 32. Then there is no matrix for such a hyperparameter because it's a simple value. Therefore, I'm going to remove this. And we just need to specify a name for that, which is going to be learning rate. Let's do this, learning rate, and perfect. All right, then the final one, the final placeholder, I'm going to copy this because this is going to be a float as well, but it's not going to be the learning rate, it's going to be the keepProb parameter. So you will see this keepProb parameter name everywhere online. You can find it on Stack Overflow. There are some nice explanations. You can find it on the TensorFlow website, I think, in a lot of GitHub pages. keepProb parameter is the parameter that controls the dropout rate. So placeholder tfloat32, perfect, and the name is not learning rate, but we can call it let's just call it keepProb, keep_prob. All right, and that's it. Now we just need to return what this function is supposed to return, which is of course all these placeholders. And therefore, I'm going to add here return, then input, the placeholders for our inputs, then targets, the placeholder for our targets, then LR, the learning rate, and keepProb, the parameter that controls the dropout rate. All right, so perfect. Congratulations, you made your first function using TensorFlow. That's very important to do this, and therefore now we're going to select this and execute. All right, function created, and now we'll move on to the next step. Until then, enjoy DeepNLP. Hello and welcome to this new tutorial. So, before we start creating the encoding layer and the decoding layer, we have to preprocess the targets. Why is that? That's because the decoder will only accept a certain format of the targets. You know, the decoder gets the targets, and in order for the targets to be accepted into the neural network of the decoder, which is an LSTM recurrent neural network, well, the targets need to have a special format. So, first of all, what is exactly this format? This format is twofold. First, the targets must be into batches. The recurrent neural network of the decoder will not accept single targets, that is single answers. Remember, the targets are the answers. So that's the first important thing of this special structure that we will create in this tutorial. So the targets must be into batches. So for example, if I take our sorted clean answers, which are the targets, well, the neural network will not accept them one by one like that. They will only accept them into batches. So instead of feeding the neural network with single answers, we will feed the neural network with batches of, for example, 10 answers at a time. And that's the first important thing we need to understand. We need to choose a batch size and then create batches of size, the batch size that we choose. And these batches, for example, of 10 answers, will go into the recurrent neural network of the decoder. So we'll have this first one here, and then the next one after that containing the 10 next answers. And that's the first important element of this special format we want to create. And then the second important element is that each of the answers in the batch of targets must start with the SOS tokens. And as you can see here, the answers start with the first word of the answer, that is the first unique integer encoding the first word of the answer, and not the SOS. So what we need to do, besides creating batches of answers, we need to put the SOS token, or at least the unique integer encoding the SOS token, at the beginning of each of these answers inside each batch. And that's the two things we will do in this tutorial: create the batches and then adding the SOS token. So how will we add this SOS token at the beginning of each answer of each batch? Well, since we need to keep the same size for all the answers, using the padding, well, what we will do is actually take all these answers inside batches and remove the last column of these answers. We will remove the last column, we will take the rest of it, that is the beginning up to the last column except the last column, and then we will make a concatenation to add the start of string tokens at the beginning of the target in the batches. So that's why at some point in this tutorial we will make a concatenation. Alright, so let's do this. Let's make this function. We're going to make a function that for any target will make this special format, and therefore the name of the function we are going to create is going to be preprocess underscore targets. All right, and obviously this preprocess targets function is going to take the targets as input because it will return the preprocessed version of these targets. So at the end, this function will return the targets in the right format, that is into batches, and where each target answer will start with the SOS token, or at least the key identifier encoding the SOS token. So targets, but then it's going to take other arguments. You might guess which ones we'll need. There are two of them. Well, first, since we'll need to get the unique identifier encoding the SOS token, we're going to take first our dictionary word to int, because this is the dictionary that maps the tokens to integers. So that way we'll get the unique identifier of the SOS token. And then, of course, the third argument is obviously the batch size, because we need to choose a batch size for the size of the batches of targets we will create. So that's the third and final argument, and now we're ready to define what this function has to do. So first of all, what we're going to do is get the left side of the concatenation. Remember, if I get this again, in each batch, let's say for example the batch size is 10, so a batch would be a batch containing all these answers here. Well, for this batch and every other batch, the left side of the concatenation will be a vector of 10 elements only containing the SOS tokens, and more precisely the unique identifiers encoding the SOS tokens. And the right side of the concatenation will be all the 10 answers in this batch of answers, but except the last column, because we don't want to get the last token. We won't need it for the decoder. So we take all these answers, but without the last token ID, because these are the IDs of the tokens. So what we'll do to make that function happen is first create the left side of the concatenation, which is a matrix of batch size lines and one column filled with the unique identifiers encoding the SOS tokens. And then we'll make the right side of this concatenation, which will be the target answers in the batch except the last token identifier of these answers, of all the answers in the batch. And then, since we'll have the left side and the right side, we'll make the concatenation. All right, so let's do it. I hope it's clear. I'm going to close this and let's make the function. All right, so we said we're going to take care of the left underscore side first. So it's just an arbitrary name I choose for a variable which will contain the left side of the concatenation. And so this left side, as we said, is supposed to contain a matrix or a vector of batch size lines and one column containing only the IDs of the SOS tokens. So how can we get that? Well, we will make that with TensorFlow. So I'm taking TensorFlow here, and the function by TensorFlow that can make this is the fill function, because basically we want to fill a matrix with the IDs of the SOS tokens. So it's fill, then parentheses, because it's a function. And so this function will take two arguments. The first argument is the dimensions of this matrix that we have to put in square brackets. And so what are these dimensions? Well, you got this. The number of lines is going to be the batch size. So batch size for the number of lines. And then the number of columns is going to be 1. Perfect. So that creates the matrix. And now we need to fill it with the IDs of the SOS tokens. And speaking of filling it, that's exactly what the second argument is about. The second argument is what we want to fill this matrix of dimensions batch size and 1 with. And what we want to fill it with is the unique identifiers encoding the SOS tokens. So let's get this. How do we get this? Well, we have to use our word-to-int dictionary. So we take our word-to-int dictionary, and in square brackets we need to enter the key identifier. And remember, the word-to-int dictionary is a dictionary that maps the words to their unique integer identifiers, and therefore the key we need to input here is the token that we have to input in quote, and that token is of course the SOS token. Perfect. So this gives us the left side of the concatenation. We have a small warning here just telling us that we just created a local variable that is not used yet, but we will use it in the concatenation. And so now we're going to make the right side of the concatenation, which, I remind, is all the answers in the batch except the last column, because it is not needed for the decoder. So right side, and to get this right side, that is the answers without the last token, well, we're going to use another function by TensorFlow that will do exactly what we want, and that is called the strided slice function. So I'm getting TensorFlow here, and then dot, and then I'm going to get this strided slice, there we go, this one, function. So what does this function do? Well, it basically extracts a subset of a tensor. So the tensor is going to be our target, and from this target, we'll make it extract everything but except the last column. So let's do this. The first argument is, as we can see here, the input, but more precisely, it's the tensor from which we want to extract something. So that's our target. Then the next argument is the beginning of the stride slice, that is from where we want to start the extraction. So that's going to be from 0, 0, that is the upper left side of the tensor. So 0, 0. Then the next argument is the end, that is up to where we want to make that extraction. And so be careful, that's where it's important to get this right, because the end has to be, well, first the batch size, because we'll want to take all the lines. We want to include all the lines, but we don't want to include all the columns. We want to take all the columns except the last one. And the trick to take all of them except the last one is to add here -1, so that it will take all the lines, because the number of lines is the batch size, right? The batch size is the number of lines in the batch, and the -1 here will make sure to get all the columns except the last one, which is okay because it's the last token, which is not needed by the decoder. The decoder will start the decoding by looking at first the start of string and mostly the context returned by the encoder, but then it will not use the last token. So with this, we have exactly what we want, that is our answers without the end. So perfect. And then is there a last argument? Well, yes, we have to specify the slide, what we call the slide, which is by how many cells we want to slide when doing the extraction. And since we want to get all the tokens in the answers except the last ones, but all of them before and for each line of the batch, well, the trick to get all of them is to use a slide of one cell by one cell. And to do this, we enter it this way, 1, 1 in square brackets. All right, and that gives us the right side of the concatenation. So now that's great. We are ready to make that concatenation. And to make this, we're going to use the concat function by TensorFlow. But the concat function will return exactly what we want. That is the pre-processed target in the right format. So I'm going to introduce a new variable here that I'm going to call pre-processed underscore targets. All right. And this will be what we want and what will be returned by the concat function by TensorFlow. So right now we need to take TensorFlow, then the concat function, and in parentheses we need to input two arguments. The first argument is a couple which contains the left side and the right side of the concatenation, and the second argument, as we see, is the axis, which is the axis along which we want to make the concatenation. So if we want to make a horizontal concatenation, the axis will be 1, and if we want to make a vertical concatenation, the axis will be 0. And since here we want to make a horizontal concatenation, we'll have to input axis equals 1. But first, let's input the couple that we have to input in square brackets. And so the couple, very simply, is composed of the left side, that is this matrix of batch size lines and one column filled with the IDs of the SOS tokens, and the right underscore side, which contains all the answers in the batch of the same batch size, of the same number of lines, but without the last token, that is, without the last column. And so there we go, we have our first argument here, and now let's input our second argument, which is the axis along which we want to make the concatenation, and we want to make a horizontal concatenation, which is encoded by 1, so we need to put axis equals 1 here. And perfect, we now get our pre-processed target, but let's not forget to return them, because this function is supposed to return the right format, that is the right data structure of the targets into batches and containing the SOS token at the beginning of each answer. All right, so let's do this. Return pre-processed underscore targets. And there we go. Congratulations, this function is over and the warning is just gone. All right, so let's select these lines and execute. Wonderful, we have our function. And now, great news, we are ready to create, finally, the encoding layer and the decoding layer of our sec-to-sec model. So we'll start by creating the encoding layer in the next tutorial, and until then, enjoy DeepNLP. Hello and welcome to this new, very exciting tutorial. In this one, we're going to start creating the architecture, eventually, of our sec-to-sec model. This architecture is twofold. We'll first create the encoder RNN layer because this is what comes first in the architecture of the sec-to-sec model, and then we'll create the decoder RNN layer. So you got this right. We have the neural network for both the encoder and the decoder will be an RNN. It will not be a simple RNN, rest assured. It will be a stacked LSTM on which we apply dropout to improve as much as we can the accuracy, and we'll create all this in the next tutorials. And today we're going to start with the encoder RNN layer, and so we're going to make a function that will define in some way the architecture of this encoder RNN layer. I hesitated to include either a LSTM or a gated recurrent unit. In fact, I first implemented a chatbot in PyTorch, and in this implementation I included a GRU, gated recurrent unit. I will share with you this model at the end of this course. But in this one, with TensorFlow, we're going to include an LSTM instead of a GRU. And for this, we're going to use the basic LSTM cell class by TensorFlow. So let's do this. I can't wait to start. Let's make this function happen. So, as I said, it's a function, so we start with def to define it. And now we need to give a name to this function. And still in the spirit of making everything crystal clear, we're going to call it encoder RNN layer. Encoder RNN layer. And now be careful. Get ready, this function is going to take several arguments. The first one is the RNN inputs. So that corresponds to the model inputs. Remember, we made this function that prepare the inputs of the models, not to be confused with the questions inputs, but the inputs like the input questions, the target answers, the learning rate, the keep prob. So that's the model inputs for the RNN basically. Then the next argument is going to be the RNN size. And the RNN size is not to be confused with the number of layers in the RNN. The RNN size is the number of input tensors of the encoder RNN layer we're making right now. So RNN size. Then the next argument is this time the number of layers, which I'm calling num_layers. All right. Then the next argument is going to be our keep prob parameter, and that we need to include it because we're going to apply a dropout regularization to our LSTM. We will first make an LSTM, but then we will apply dropout, so we will have a stacked LSTM with dropout, and this again is to improve the accuracy. So keep prob, that controls the dropout rate, and then a final argument, sequence_length, which is the list of the length of each question in the batch. All right, so that's the list of the lengths of the questions inside each batch. And that's it. Our function is ready to be defined. Okay, so first we will create the LSTM. How will we create it? Well, thanks to TensorFlow, we have an amazing class that allows us to create it in a flashlight in actually only one line of code, and that's the basic LSTM cell class. Therefore, what I'm going to do right now is introduce a new variable that I'm going to call LSTM, but that will actually represent an object that will be an object of the basic LSTM cell class. And therefore, what I'm going to do right now is get this basic LSTM cell class from TensorFlow. And so we need to start by getting TensorFlow here, which has a shortcut TF. And then from TensorFlow, well, we cannot directly get the class in TensorFlow. We need to go through first the contrib module, then the RNN submodule, and then from there we can get the basic LSTM cell class. So let's get it. It is spelled this way. Be careful with the capital letters. Capital B, basic, LSTM, all in capital, and capital C-E-L-L, basic LSTM cell. And in parentheses, we need to input just one argument, which is our RNN size, which I remind corresponds to the number of input tensors in the layers. Let's input this, RNN size, as we called it. This is one of our arguments, RNN size, and there we go. We now have our LSTM. Perfect. So now we're going to apply dropout to this LSTM. So basically now what we'll get is the same LSTM, but on which dropout was applied. And therefore the new variable I'm going to introduce here is LSTM_dropout. Well, you can call it however you want, but with this name of the variable, it's quite clear that we are just getting the same previous LSTM, but with dropout applied. So LSTM dropout, and to apply dropout, well, again, that's going to be very simple. We're going to use another class, which is a dropout wrapper class, and which is some kind of wrapper that can wrap an already existing LSTM, which is the one we just created, but with dropout applied. So I remind that dropout is the technique of dropping out, that is deactivating a certain percentage of the neurons during the training iterations. So the usual dropout rate is 20%, which would mean that during the training iteration, 20% of the neurons are like non-existing. Their weights are not updated. So that's why they are in some way deactivated. So that's the dropout. And so to apply it, well, we'll create a new object of the dropout wrapper class, which will of course get as one of its arguments the LSTM object we just created. So let's do it. Let's get it from TensorFlow, of course. TensorFlow. Then again, we need to go to the module contrib, then RNN again, and from this RNN module we get the drop out, so with capital D and then capital W wrapper class. All right, and this class takes several arguments. The first one is the recurrent neural network you want to apply dropout on, and that's of course our LSTM object that we just created here. So LSTM, and then the next argument is going to be our keep prob. Of course, because keep prob, I remind, is to control the dropout rate. And since now we're dealing with dropout, well, that's the time to use keep prob because it will control the dropout rate. So I'm adding here keep prob, but I will specify that keep prob is the input underscore keep prob parameter. So that's the name of one fixed argument of dropout wrapper. This is not an arbitrary name I'm choosing. This is part of the class, but this argument should be equal to the keep prob argument. That is the argument we will input later of our encoder RNN layer function. So keep underscore prob here. Perfect. So now we have our LSTM with dropout applied. Great. Now, next step. The next step, now that we have our LSTM with dropout applied, LSTM dropout, we're ready to create the encoder cell. And we can only create it now because we're going to create it through, again, a very useful class by TensorFlow, which is the multi-RNN cell class, and which takes as argument, well, of course, the LSTM with dropout applied. This LSTM dropout object by the dropout wrapper class. So what we need to do now is introduce a new variable encoder cell underscore cell that will be the cell of the encoder, not to be confused with the state that we will create right afterwards. So that's the cell, and to get it, well, this will actually be an object of this multi-RNN cell, which we'll get again from TensorFlow, and then from the contrib module, and then from the RNN submodule, and then there we go, we can get the multi-RNN cell. Be careful with the capital letters. And then this class is going to take several arguments. Well, first, the LSTM dropout layer we created here, times the number of layers to specify how many layers we want in our encoder RNN. And therefore, how do we put this? Well, we first need to input our LSTM dropout layer in square brackets like this. So in square brackets, I'm including our previous LSTM dropout object. And then to make it several layers, well, I'm multiplying it by another argument that we have, and that gives us exactly the number of layers we plan to have in our encoder RNN, and which is num underscore layers. Num underscore layers, which will create the encoder cell. I remind, if you have not followed the intuition lectures, or if this is pretty new for you, well, the encoder cell is composed of several LSTM layers, and besides, we applied dropout to each of these LSTM layers. That's the encoder cell, and again, if this is pretty new for you, I highly recommend to have a look at the annexes, and especially the second annex at the end of this course, because we explain the whole theory of RNN, so that will help you understand the difference between cells and states. Alright, so perfect, now we have our encoder cell, and now, of course, we'll take care of the encoder state, and to get it, we're going to get it from the bidirectional dynamic RNN function by the NN module this time. It's a new module, like in PyTorch, the NN module by TensorFlow, and this will get us exactly what we want. That is the output, one of the output of the RNN, which is the state. And so we're going to call this state encoder state. Sorry again for the long names of the variable, but that's because we will have then the decoder cell and state, so I just want to make the clear difference between those. So encoder state, however, the encoder state is going to be returned by the bidirectional dynamic RNN function by TensorFlow, but which returns two elements. One of them is encoder state, but encoder state is the second element returned by this bidirectional dynamic RNN function. And therefore, to only get it, because we only need it, we have to add here an underscore and then comma to specify we only want the second element returned by this future bidirectional dynamic RNN function of TensorFlow. And speaking of TensorFlow, that's what we need to get first to get this function. So tf dot, then remember we get it from the NN module, inside the TensorFlow library. And then from this NN module, we get the bidirectional underscore dynamic underscore RNN function. And this creates a dynamic version of a bidirectional record renewal network. Remember, I told you we're not going to make a simple record renewal network. We want to make our chatbot as powerful as possible, and creating this dynamic version of a bidirectional record renewal network will definitely help. So this dynamic version of bidirectional RNN basically takes your input that we're about to enter right now and will build independent forward and backward RNNs. But be careful, when you build this kind of bidirectional dynamic RNN, you have to make sure that the input size of the forward cell and the backward cell must match. That's the first thing we'll make sure of when entering these arguments. So let's do it. Let's take care first of the forward RNN. The argument for it is cell underscore FW forward, and this will be equal to our encoder cell object from the multi-RNN cell that we just created in the previous line. Therefore, the cell forward here is going to be equal to encoder cell. Then, next argument is going to be for the backward RNN. And the name of the argument for that is cell underscore BW, backward. And this one is going to be equal to, again, the encoder cell, because it's like a bidirectional record renewal network that we're making, meaning we have both directions, but on the same encoder cell. All right, so the cell backward here is going to be equal to the encoder cell again. Then the next argument is going to be the sequence underscore length, which I remind is the list of the length of each question in the batch. So sequence length, which this one is the name of the argument inside the existing bidirectional dynamic RNN function, but we have to set it equal to the sequence argument, which is one of our arguments of our function that we're making. Okay, then next argument is going to be our model inputs, which are one of our arguments here, the RNN inputs. So inputs, which is the name of the argument of the bidirectional dynamic RNN function, are going to be equal to our RNN inputs argument. And then finally, one last argument, the D type, and this has to be equal to the float 32 type by TensorFlow, tf.float32. It's important to include it to make sure we are dealing with floats. All right, so congratulations, you made the first pillar of this sec-to-sec architecture, the encoder RNN. And so now, of course, we simply need to return the output of this encoder, which is, of course, I remind, the state and not the cell. The cell will be part of the loop in the RNN, but will not be the output. The output is the encoder state that we got in our last line here. So we have to return it, and to return it, there's nothing more simple. We simply need to add return encoder underscore state. And there we go. We have our first function created that creates the encoder RNN layer. Perfect. So now we're going to move on to the decoder, and it's not going to be that simple. We will do it in 3 tutorials because we're going to make some cross-validation to separate some training data and then some cross-validated data. So that's cross-validation. That's very important to reduce overfitting and improve the accuracy on new observations. So we're going to start by making that separation between the training data and the cross-validation data, and then we'll be ready to create our decoder RNN layer. So let's do that in the 3 next tutorials. I'm going to execute this, and until then, enjoy Deep NLP.